The roof structure is generally a steel truss system, which can be designed for metal sheets or tiles. This is a roof truss system which typically consists of C75 or C100 sections as the core and web members of the truss. The steel roof framing system can suit all types of roof design. For example, hip, gable, Dutch table, steel roof sheeting or tiles, and will be screwed directly onto the wall frame. When using tiles, wooden style roof trusses are used with purlins running across them for the tiles to be fitted. Steel is widely used in the construction of multi-story buildings. However, steel construction is seldom used and is traditionally considered uneconomical for landed properties. Over the years, various improved systems have been developed for use in landed properties. This line gauge steel frame is developed through a cool form process without the use of heat. This process enables steel manufacturers to produce lightweight but high tensile steel sheets. The sheet surface is coated with a zinc alloy that completely covers the steel surface and seals it from the corrosive actions of its environment. This results in buildings that are more solid, rigid, stronger, durable, and easier to build. As such, the light gauge steel frame system is an attractive alternative for use in landed properties. This is particularly in view of concerns on the depletions of timber resources and low productivities associated with reinforced concrete construction. Thus, we are going to talk about the installation process of roof trusses.
Handling. Most steel trusses are delivered to job site ready to be installed, but they still must be handled with care. The contractor is responsible for properly receiving, unloading, and storing them. They should carefully remove bending or metal attachment pieces to avoid damaging trusses and prevent personal injury. And they also should avoid lateral truss bending. The trusses may be unloaded directly on the ground at the time of delivery or stored temporarily in contact with ground after delivery. If the trusses are to be stored horizontally for more than 1 week, place blocking of sufficient height beneath the stack of trusses at 8 feet to 10 feet on center. Bracing and restraint. To ensure correct and safe installation of steel trusses, temporary and permanent bracing is required. During construction, before all of the components of the truss system are in place, bracing acts to hold members upright, straight, and in place. A stabilizer can provide the lateral installation restraint for cold-formed steel trusses. The following is an important step of roof trusses installation. First is the stage trusses. Next, leave first individual truss in place. Long trusses will require a spreader bar. Next, secure truss to bearing support with specific hardware. A screw gun can install hardware at the bearing support and bracing material. For the first truss, the truss is restrained with bracing to the ground or building interior. Leave second truss in place. Secure second truss to bearing support with specific hardware. Secure second truss to first truss with installation bracing like a stabilizer or other material on the top chord, bottom chord, and web plan per provided documents. Diagonal bracing is critical. And repeat for the following trusses. Hoisting and connecting. Cranes and scissor lift are two of the most commonly used pieces of machinery on a job site to hoist steel roof trusses to the support and be braced. Cranes may lift one trusses at a time or a pre-packaged bundle of trusses lift to the installation point at one time. Screws are the mechanical connection of choice at any given job site to connect bracing material to the trusses. Clips to make truss-to-truss connection and clips to attach truss to the bearing members. Features like quick loading screw strips and a patented auto advance mechanism will ease the installation. Do not overload the crane. Do not rely on bending or metal pieces used to attach trusses in a bundle to hoist and move bundles on job site. Leaf points for hosting truss bundle are permitted anywhere along the top chord. 2 leaf points may be used for bundle with trusses up to 45 feet. Use at least 3 leaf points for bundle with trusses greater than 45 feet.
Truss installation. Like any roof truss, steel roof trusses are best installed by crane and an experienced crew. There are a number of industry best practices for installing trusses. The most critical are discussed below. Trusses should never be attached rigidly to interior partitions. This can induce bending forces that trusses aren't designed to carry. Rigidly attached trusses have also been known to lift a non-load-bearing interior wall from the floor. The truss installer should always follow any special instructions by the manufacturer. For example, T-bracing, a common web strengthening technique, is best applied on the job site. Failure to install the bracing can drastically alter the strength of the truss system. Most roofs, regardless of their location, are designed with a fixed end and a slight end. This approach significantly reduces the amount of lateral force on the walls supporting the truss system. Strengthening walls against lateral forces, particularly at the top of the wall, is difficult. Therefore, the approach is to reduce lateral force on walls by allowing the truss to slide horizontally. Several manufacturers make so-called slide connections, which allows the truss to move horizontally and at the same time preventing any sorts of vertical movement. Trusses should never be modified or cut without first seeking engineering advice. If the truss was damaged during shipment, the installer should contact the truss engineer for a workable repair scheme. If possible, the crane should be positioned before the roofing materials and trusses are dropped at the site. This assures that materials will not need to be moved again after delivery. Before lifting trusses to the roof, the crane hoists the sheeting and finished roofing to the top floor. While the floor materials go up, gable trusses should be sheeted and sided while still on the ground. This saves time and eliminates the need to set up tall staging at the gable ends. So, before installing roof trusses, there are a few inputs required to truss manufacturer. Truss type determines whether there will be storage or living space. Also defines architectural details such as soffit, overhang, fascia heights, and tail length. Location determines the building codes and loads that apply. For example, in Western California, seismic requirements may drive the design and cost of the truss. In coastal Florida, it's wind that drives the design. Open category determines the proportion of openings, such as doors and windows, to the overall wall area. Door and window openings can increase the pressure inside a structure during wind loading conditions. Wind exposure category determines the amount of wind the structure will be susceptible to. Building category determines the type of structure such as hospital, school, or even residential. Desired roof slope. Pitch influences many of the design parameters and consequently has an impact on the overall truss weight. Building plans. Building plans provide the truss designer, manufacturer valuable information on the wall types, thickness, spans, chord slopes, and even more. Open category and wind exposure are optional inputs. The truss manufacturer will determine whether these are provided based on the building location and description.
We have visited a site which is located in SS16, Subang Jaya. It is a LRT project which finished in February 2016. Tri-Arcs Sendirian Berhad is the main contractor of this project. Mr. Lu, the site QS, has roughly explained to us about the LRT project. He told us that all the metal roof trusses are pre-made in the factory and took the structure of I-beam. The band and curved trusses are manufactured by melting the metal truss to a certain temperature and bend it to form the size required. By and large, we were there to observe the steel roof structure installation process. It goes without saying that we learned a lot and gained a lot of experience through this site visit. And we had a short interview with Mr. Lu.
对，再就是可以大概讲一下整个他现在录不多啊，大概一般上我们是做完，那典型就是来宾很多，帮我们寄上去烧，标定全部在厂标定，然后做2个sample出来，对，就这样子，大概多个。这里2个，再来，然后从1个上去。那全部已经在厂那边弄好了，再来这边装了。再来这边装，对。再来好像你们装这些roof啊，它有点像我的水，需要管防水之类的。我的铺吧。那我另外他唯一就是有个铺吧。我的铺啊，肯定有像我可以检查的很多，可以检查的啊，那个是他们很多，然后到最后了，它也是有防水的，有，你看啊，主要它是因为我有分几种pack嘛，每种pack可以防到，到什么pack？好不好？是它那个一定要有一层是防水，有一层一个防水的啦。那我就可以在外面还有几层还层是防水，还层是防水机，哪个是我不决定，反正它会跟它生气，是哪个防水。
And this is the ending of our construction technology video. Thank you for your patience.